Hello everyone, good day. Today we will be discussing about systems, classification of systems. Okay, and we're going to identify what kind of system do we have, no, from the given. Okay, so previously we have been discussing all about signals, no. So the property of signals, nature of signals, basic CT and DT signals, even the uh, operations, basic operations of signals. No? So, today, no, let's talk about systems. We have already discussed what system is about. No, so uh, by definition, when we say system, this is any physical device that performs operation on the input to generate an output signal. Okay, so this is if you're going to look at point rather image A. No, so this is the general representation of a system. We have an input signal fed into the system, then the system will perform the necessary operations indicated, then generate an output signal of Y. No, so this could be X of T if it is a CT signal and X of N if it is a DT signal. Okay, this also may be regarded as a mathematical model of a physical process that relates to the input signal to the output signal. So, um, it is easier for us, no, to perform the operation indicated by the system if it is in a mathematical model because it's direct to the point. No, let's say for example, amplitude scaling, it's just multiplied. No, if it is shifted up or down, it is just added, no, to the amplitude. No, so if time shifted naman, no, so nandun siya sa loob nung time variable natin. Okay, so this is general representation of a signal. Y is equal to t times x. Okay, where y is the output signal, t is the operations involved in the system, and x is the input signal. Okay, this image, no, etong part B, this is what we call a multiple in, multiple out system because it is possible, no? We have parallel inputs, okay, fed into one system, then the system will generate certain number of signals, no? It can be equal, it can be lesser, it can be greater, no? So, ayan, sige, i-ano natin, wait lang. So, this is a multiple in multiple out system or a MIMO system. Ayan. Okay, so that's what we call this kind of system. Pag multiple, pag more than two or more rather, two or more yung input and yung output, okay, so that's MIMO system. Now, let's go to the classification of systems. The classification of systems is the first one is based on the type of signal being fed and being resulted, no? So let's say for example, if we're going to have an input signal and output signal that is CT, okay, or a continuous time signal, so therefore the system is also continuous time, no? So we call it continuous time system or CTS. Okay, so in just like in CT signals, okay, time is measured continuously. Okay, and a system that is continuous time based, okay, is described by ordinary differential equations, algebraic equations, polynomial equations, and integral equations, and etc. No, all other equations aside from difference equation. Why? Because difference equations are related to discrete time systems. No, so when we say discrete time systems, these are systems that has an input and output of DT signal. Okay, and when we talk about DT signal, okay, time is measured at discrete instance or discrete intervals. Okay, so we are just using the same representation, no? Iniiba lang natin yung sa input and yung sa output natin. Of course, pagka x of t that is ct, kapag x of n that is discrete, no? So, but the representation of the system are just the same, no? Parehas lang sila. Okay, now let's go to the causality. No, so when we say causality, this is the property of a system to anticipate the output, or rather to anticipate an input to produce an output. Okay, why? If the system is said to be causal, okay, if the system is said to be causal, meaning the system is not anticipatory, meaning we are not expecting, or the present output, okay, is not dependent, okay, to the future input. Okay, it is only dependent on the present and the past values of input x. No, so wala tayong makikitang time shifting na positive. No, so kasi kapag rather negative, no? Kasi kapag negative yung time shifting natin, no, so that is already a non-causal system. Meaning there is a dependency on the future input of the system, no? So again, ano, kapag causal yung ating system, not anticipatory, no? So we are only dealing with the present, yun yung pinaka-important, present and past values of input x of t. Okay, so ang example natin dito, ito, y of t is equal to x of t minus 1 with t minus 1 having the delay. Okay, then we have y of n is equal to x of n over 2, no? So we are just we are expanding, no? So yung kabaliktaran ng compression, no? So we are expanding the signal. Okay, then kapag non-causal naman, so again, sabi ko nga kanina, so may dependency tayo sa future. Okay, so meron tayong time shift involved, pero ano siya, advanced, no? So positive, rather negative yung nakukuha natin, because remember, 'di ba, by default we have x of t minus k, no? Yun yung representation natin, and our k here is negative 2. Okay, so dito naman ganun din. So if you're going to rewrite this is x of negative n plus 1, 'di ba? So meron kang time fold, okay, time reversal, then meron ka ring advance, no? Meron kang time shift na advance. Okay, so that is for causality. Next, let's talk about linearity. So if we're going you have already encountered the concept of linearity since differential equations, 'di ba? So or rather even in calculus pa, no? So when we say linearity, okay, this is the combination of both homogeneity and additive property. So sorry, correction on this is additive. Yan. So when we say that a system is linear, okay, ito based to points, no? So homogeneity. When we talk about homogeneity, so meaning if you're going to scale the input, the output will be scaled at the same rate. No, hindi dodoble, hindi kakalahati. So dapat equal sila. Let's say if we're going to multiply, look at this. So if we're going to multiply k to x, therefore your y should also be multiplied with k for this system to be homogeneous. Okay, likewise, okay, if we're going to add two signals, okay, let's say x1 and x2, okay, so these two signals correspond to a certain output signal individually. But if we're going to add both input signals, okay, yung corresponding outputs nila, pag kinuha mo yung sum, yun yung lalabas. Hindi magbabago. Okay, so to combine these two, okay, to form the linearity, so say we have a multiple inputs x1 and x2 added together while scaling as well. So we have a constant 1 and constant 2. So we will arrive with k1 y1 plus k2 y2. We can extract k if they are the same, okay, and we can check the additivity, meaning we will arrive with the same correspondence from the input to the output. Okay, so a linear system is one in which all the interrelationships among quantities involved are expressed by linear equations. It can be algebraically, it can be differential, or it can be an integral equation. Okay, so when we are talking about linearity, always superposition principle is applied, no? So we're just getting the sum of everything. Okay, then hindi magkakaroon ng changes. Okay, circuits containing linear elements or RLC, no? Ano yung mga RLC natin? This is resistor, L is inductor, this is L, and we have capacitor. So this is C. So kapag daw yung ating system is entirely composed of these three, then therefore our circuit is a linear system. Okay, so if there is at least one non-linear device, say rectifier, diodes, transistors, IC, op-amps, etc., okay, automatic our system is non-linear. Okay, so basta RLC lang, okay, automatic linear yung natin, yung circuit natin. Okay, now let's go to time variance. We will be talking about in the next chapter, after we have talked about classification of systems, we're going to talk about LTI systems. So medyo i-advance ko na ng slide. When we talk about LTI systems, this pertains to linear time invariant systems. Okay, now, when we talk about linear time invariant system, the system should possess both linearity and time invariance. Okay, ano nga ba si time invariance or ano ba si time variance? When we say time variance, okay, one or more parameters in the system vary with time. Meaning, if you have a certain output x of t, say, this yields to y of t. Tama? 'Di ba? So, if we're going to perform a certain operation. Now, if we're going to time shift, okay? If we're going to time shift, let's say, excuse me, let's say t naught. Okay, mag-iiba yung, alin? Yung output. Hindi siya magta-time shift but rather magkakaroon ng change in the output. Kaya magiging time varying system yung ating system or it is a TVS system. It is a TV system. Okay, so for CT, okay, so TV systems are described by time varying differential equations and for DT naman, time varying difference equations. Okay, so let's go to time invariance. So, pag time invariance, no, let's use the previous example. A certain input, okay, so operated with t to produce a signal y of t. Okay, and if the system is time shifted, say t naught, okay, the output will also be time shifted. Hindi magkakaroon ng changes dun sa output irrespect with time. No, so, no, makikita natin dito. So, say if you have t of x, t times x of t minus tau, so that will just yield to y of t minus tau, where tau is the time shifting coefficient. Okay, likewise, so pagka discrete naman, so that is m, no, n minus m. Ganun din yung mangyayari kay output, no, y of n minus m. Okay, so this is the representation ng sinasabi ko kanina, no. So originally, if we're going to look at this time varying system, we have a half sinusoid input and it produced a triangular output. Okay. However, if the signal is shifted from T1 to T minus T plus tau rather and T2 to T2 plus tau, okay, nagkaroon ng change in the output. No, hindi na siya triangular pulse. Ano na siya? Para na siyang exponential logarithmic function. No, so na combine. So nagkaroon ng change dun sa output natin. So therefore this is a time varying system. No, so unlike kapag time invariant naman yung ating system, okay, if we have, let's say, a triangular pulse, okay, from T1 to T2, the output is a rectangular pulse also from T1 to T2. On the same time reference. However, if going to shift the time range, okay, from T1 and T2 to T1 plus tau and T2 plus tau, okay, the output is still a rectangular pulse, but the time range is shifted as well from T1 to T2 to T1 plus tau to T2 plus tau, or rather T3 plus tau. Sorry, hindi ko masyado nakita. Okay, so yun yung kinaiba ng time varying system sa time invariant system. Okay, so again, we're just going to talk about linear time invariant systems in the next chapters. Now, let's talk about memory. So, some systems have memory, others do not have. Okay, when a system has memory, meaning the current output is dependent on the past, present, and or future inputs, that is what we call a dynamic system. No, so this is a with memory system. No, yung ibang books kasi tawag dito with memory. Ayan. With memory system. So, ayan pala, nakasulat na pala, no? So, systems with memory. However, if the system does not depend, okay, with past or future, it only depends on the current input. Therefore, the system is static or instantaneous, or sometimes it is called memoryless systems. Okay, so, for example, okay, say y of t is equal to 2x of t. Okay, so walang time shift na naganap. Okay, so this is a static system. Now say y of t is equal to 3 over 2x of 2t. Okay, so wala naman time shift na naganap, although merong compression. Okay, pero since walang time shift na naganap or walang time shift na involved, so this is a static system. Okay, whereas or a dynamic system, let's say y of t is equal to x of t plus x of t plus 1. Okay, so meron tayong this is a meron tayong advance na involved, no? So meron tayong dependency sa future input because of x of t plus 1. Likewise, So say 2x of t minus 2 plus 3x of 2 plus, rather 2 minus, let's say, x over, sorry, but bakit x? That should be t. Teka, ayusin natin. So, this should be t. Ayan, ayusin natin. Wait lang. Ayan, so we have here t. Ayan, so meron tayong dependency on the future and past output. So therefore, this is what we call a dynamic system as well. Okay, so malinaw po 'yon, ano? Okay, now let's talk about this particular system, what we call a feedback system. Okay, a feedback system is a special class of systems with, of course, from the name itself, feedback. Meaning, the output signal is what? Operated back to the input. Okay, or added to the input. So, say for example, no, x of t, okay, so this goes into the accumulator, okay, to this. Then the output of the accumulator goes into the system and produce in an output of y of t. However, this output y of t goes back, okay, to the accumulator for the next input. Okay, so susunod, let's say kx of t plus 1, or rather kx of x of t plus 1. Okay, so yung kanyang input is what? Ano na siya? X of t plus 1 plus x of t. So that's what we call a feedback system. Okay, so bumabalik, no, merong cyclical operation. Okay. Describe if the given system is linear or non-linear. Okay, now let's go to the example. So, gamit tayo nung properties natin, no. So, the first thing that we're going to do is we're going to change y. Okay, or rather, our identity for y should be a of y1 or as b of y2, or say a k1 y k1 y is equal to k1 y1 plus k2 y2, walang problema, no? So I just use this for simplification, for simpler representation. Okay, plus bx2. Okay, now first things first, we are going to change y with y1. Okay, so we start with dy over dt. So we have y1, then plus 4 y1 of t is equal to 2x1 of t. Then, ganun din yung second equation natin. But instead, we're going to use y2. Okay, now, so we're going to multiply. For the first equation, we're going to multiply a. For the second equation, we're going to multiply b in adherence to this condition. Okay, for y1 and x1, we're going to multiply a. For b, or rather for y2 and x2, we're going to multiply b. So we have here d over dt. Since constant yan, pwede natin ipasok sa loob. Plus 4ay1 of t is equal to 2ax o x1 of t. Now, for this, we have b, okay, plus 4by2 of t is equal to 2bx2 of t. Okay, so yan yung multiply, no, yung na-distribute na natin yung ating constants. Now, let's add both equations, no. So, first, check what are the same, no? Dapat same sila ng order kung derivative yan. Kung constant, kung coefficients, sorry. Kung variables naman, dapat same sila ng variable. Okay, so in this case, so d over dt, meron tayong derivative. So that's ay1 plus by2. Okay. Then we have plus 4ay1 of t plus 4by of y2 of t. So, since common si 4, pwede ko siya ilabas. Ayan. Then this is equal to 2ax1 of t plus 2bx2 of t. So, that is factor out yun si 2. So, we have ax1 of t plus bx2 of t. Ayan. Okay, now, let's check these terms, no? So, balik tayo dito sa yung una nating sinulat na equations, no? So, ay1 plus y2 is just y. Okay, so we can write this as if this. Plus 4, ay1 of t plus by of t, ganun din yon. So, si y, palitan lang natin ng y of t. Okay, which this will yield to y of t, which is equal to 2 times this, no? So, ax1 of t plus bx2 of t, so that is simply x of t. Now, after you have substituted, no, so check the original equation. Okay, this, are they the same? If they are the same, okay, then therefore this is linear. Ayan. Okay, therefore this is linear because it's the same from the original function or dun sa ating system, no? It just went back to the original system. Okay, so I hope malinaw po, no? So let's try number 2. Post nyo muna, then after you've post, erase. Okay, so let's have y of t is equal to 2x of t minus 5. So ganun din. Oops, sorry. So we have here, oops. Y is equal to a, palitan natin, no? Gamit tayo ng k, no? Para hindi naman, para makita ninyo it is just used the same way. Then we have x. Okay, now let's substitute y of t and x of t with y1 and y2 respectively. So we have here y1 of t is equal to 2x1 of t minus 5. Then we have y2 of t is equal to 2x2 of t minus 5. Okay, now, let's multiply k1 here and k2 dito sa kabila. So we have k1 y1 of t is equal to 2k1 x1 of t minus minus 5k1. Dito naman, so we have k2 y2 of t equals, so 2k2 x2 of t minus 5k2. So let's add both equations. So k1y1 plus k2y2. So we have k1y1 plus k2 y2. Next, equals, so 2k1x1 plus 2k2x2. So we have 2 times k1x1 plus k2x2. Okay, now, so we have your negative 5k1 plus negative 5k2. So that is plus, or rather minus 5k1 plus k2. Okay, now, let's use the original given again. So this is just y. So we have y of t is equal to 2x of t. Okay, plus, of course, this is x of t, diba? Then ito, si k1, k2, wala naman tayong k1, k2 dito. So as is lang yan. So that's minus 5 k1 minus 5 k2. Or pwede nyo naman kahit hindi na-distribute. Now, so, since nag-iba yung ating final answer dito, no, because of the addition of negative 5k1 plus k2, okay, lagyan natin ito. Or negative 5k1 plus k2, ayan. Okay, so, since nag-iba nga yung ating output, okay, hindi na siya parehas dito sa given, therefore this is non-linear. Ayan. Okay, so this is non-linear. So I hope malinaw, no, how we solve yung linearity, okay, of a system. Okay, now, let's go to this next example. A modulator with carrier frequency of omega c gives an output y of t is equal to x of t cosine omega c t t. Okay, first determine whether the system is memoryless, the system is causal, or the system is time invariant. Okay, so first, now let's check with memoryless. When we say memoryless again, so the output, okay, should not depend on past and future inputs. It should only be on the present. Okay, now if we're going to check again, so we have y of t for the general representation. Y of t is equal to t x of t. Okay, which is equivalent to x of t. Ano yung pinakati natin dito? Yung operator natin, that is cosine omega t, because that's the modulator. No, so since the input, okay, wala tayong nakikitang time shifting, wala tayong nakikitang t plus something or t minus something. Okay, therefore this is memoryless. No, so tama na yung ano natin dito. So this is memoryless. Okay, next, so is the system causal? When we say causality, okay, so it does not depend on future output. On future values of y of t. Now, rather x of t. Now, wala nga tayong time shifting na involved. Okay, so automatic this is also causal. No, so basta walang future, walang x plus something. Okay, so that is ang tawag dito, causal. Okay, next, so is the system time invariant? Okay, now let's have our y1 of t, okay, be the output of the shifted input. So remember, diba, originally y of t is equal to x of t cosine omega c plus t. So let's represent y1 of t as the output of the shifted input. So our x1 of t is equal to x of t minus t naught, let's say. Okay? So if this is the case, okay, therefore our y of t, y1 of t, y of t, walain ko lang. Ayan. Okay, so our y of t minus t naught, because remember our x1 of t is represented with t minus t naught. Okay, so this is also equivalent to x of t minus t naught. Okay, cosine omega c of t minus t naught. Okay, which our original, going back dun sa ating y1 of t, okay, that is not equivalent to this. Why? Because our y1 of t is equivalent to x of t minus t naught, okay, cosine omega c t. Walang time shifting involved saan? Okay, doon sa ating modulator. Okay, if that is the case, since they are not equal, okay, therefore this is time variant. Okay? So I hope malinaw po, So kapag hindi nagtugma yung output doon sa dun sa shifted output doon sa original output, okay, then therefore hindi sila tugma. Hindi yan time invariant. Okay? So next. Yan. So we have different applications of signals and systems. So of course, mainly we are talking about electric circuits. So for example, in this case, we have x of t as our input signal. Okay, this signal is then propagated throughout the circuit, pabalik. So dadaan siya kay resistor, dadaan siya kay inductor. This is an example of an RRL circuit, first order differential equation, na transient circuit. Okay, so this is one example. Okay, so we have also the square law device. When we say square law device, either current or voltage depends on the square of the other. So we have here y of t is equal to x squared of t. Okay, this is also known as a signal multiplier. Okay, this can be built by using operational amplifiers and diodes. Okay, so since this is a square law device, a signal multiplier, okay, this is a nonlinear static system commonly found on radar and communication devices. So para siyang feedback system, pero hindi sa output nang gagaling yung second input. Saan nagagaling? Dito pa rin sa saan? Sa input pa rin. Kumbaga nag-split lang, parang kinloan, no? So that's the term. Kinloan yung signal. Okay, so that's what we call a square law device. Okay, and last, no, our DSP system, our digital signal processing system. Okay, now, we have two kinds of signal processing. We have the analog signal processing and the digital signal processing. When we say analog signal processing, we're talking about analog signals operated by an analog processor, okay, and produce an output analog signal din. Okay, so walang digital values involved dito, no? Walang digital signals involved. The thing with analog signal processing, no, first, it is very resource consuming. It requires higher power requirements. Now, why is that so? Because there is no limit on what amplitude, no, can the analog signal processor can handle. Okay, so like we can feed any type of signal. Let's say anong best example ng analog signal processor natin? Megaphone. Okay, so yung mga traditional megaphones natin, no, meron lang kasi mga digital megaphones ngayon eh. The voice that the mic of the megaphone is receiving, ina-amplify lang niya analogly. No, like ini-scale, no, para tumaas yung amplitude. Okay, so ganun nangyayari yun sa analog signal processing natin. Whereas for digital signal processing, what happens is the analog signal, the original analog signal, is converted through the analog digital converter. Okay, then the analog digital converter produces an equivalent digital signal. Okay, so this digital signal, okay, this is already in the form of pulses, no? So meron lang siyang equivalent na code. Okay, then this digital signal is being fed into the digital chip or the DSP chip, the digital signal processor. Okay, then this produce another digital signal. Excuse me. Okay, so ganun yung nangyayari. Then, this digital signal that's the output from the processor is then reconverted or reconstructed back into an analog signal, on the nearest equivalent analog signal, through a digital analog converter. No, so, meron siya para lumalabas tatlong stage. ADC, then digital processor, then DAC. Now, before, we arrive with another analog signal. Ayan. No. So, ganyan nangyayari, no? What's the advantage? Sir, mukhang mas komplikado pa yan, ah. Remember that digital signal, digital processors has very efficient power resource management. No, yung mga chips natin requires digital chips natin requires lesser power compared to our analog processor counterparts. No, so kaya very efficient ang pagko-convert from analog to digital. So totoo lang. No, so the thing is that syempre dapat maganda yung pagka-convert mo from analog to digital and digital to analog. Because if very poor yung resolution ng mga converters mo, hindi niya makukuha yung original, yung pinakamalapit dun sa original signal natin. No, so medyo ano siya, reliant siya dun sa resolution rate ng ating converters. Okay, now let's solve this problem. No? So consider the given RC circuit, find the relationship between the input and the output signal. Okay. So what we're going to do is, okay, let's solve this, no? Using Kirchhoff's voltage law. So alam naman natin 'yan, 'di ba? So, sorry. So we have here, so by KVL, okay, so let's have here, of course, we know that the summation of the voltage sources is equivalent to the summation of the voltage drops. Okay, so ano yung input natin dito? So we have our Vs of t. Okay, and what are the drops? Now, of course, the voltage across the resistor plus the voltage across the capacitor. Okay, now, via Ohm's law, we know that the voltage across the resistor is just defined by the Ohm's law, no? I is equal to V over R. So, which means V is equal to IR. Okay, although, syempre, hindi naman na to circuits 1, no? So, we're going to represent I as an instantaneous current, okay? At current respect to time. Okay, so, you're going to rewrite this as Ri of t. Okay, with the current as a function of time. Okay, then plus. Okay, so we have here VC of t. Now, what is the relationship of our VC of t and our I of t? Our I of t, no, sulat ko dito sa may taas, in terms of the voltage of the capacitor, okay, that is equivalent to the capacitance multiplied to the derivative of the voltage of the capacitor in respect to time. No, so, what we're going to do? So, we're going to substitute I of t, okay, with this. Kasi, remember, we are getting VC of t as our Y of t and Vs of t as our X of t. So, nararapat lang na si I of t palitan natin to have VC of t changed into dy of t, or rather Y of t. So, we have here X of t is equal to R times C, okay, multiplied to the derivative of VC of t, which is Y of t, over dt. Okay, then plus, okay, we have our Y of t. Okay, so since this is a first order differential equation, no, so this is a linear differential equation, so we can just multiply 1 over RC, okay, to remove this 1 to arrive with this, no, so our differential equation d over dt of Y of t, okay, plus 1 over RC Y of t is equal to 1 over RC X of t. Okay, so this is the answer to the first problem. Okay, this is the relationship of the output in respect to the input. Okay, now, we have here for the second one, no, so X of t is equal to Vs of t pa rin. However, Y of t is now equal to I of t. So instead, okay, instead of dc of t over dt, we're going to change this, okay, instead of I of t in respect to Vc of t, we are going to have Vc of t in respect to I of t. So, we have here, we're going to transfer C on the other side. So, that is 1 over C I of t is equal to dVc of t over dt. Okay, syempre, to remove the derivative, we're going to integrate. Okay, so, since this is a time-varying system, time-dependent system. Okay, so we're going to assume that the circuit, okay, started at negative infinity. Why is that so? Even though we are not turning, let's say we're not turning on if there is a switch here, okay, technically gumagana yung circuit in the sense na may nakaabang ng current. Hindi lang natin alam kung kailan nag-start kasi hindi naman natin alam kailan sinaksak, 'di ba? So, in this case, so wala naman tong switch, so meaning the current is rather the voltage is constantly supplying the two components. So, if that is the case, okay, we're going to have the limits from from negative infinity, okay, to t. Okay, to t. So, why is that so? Bakit papunta kay t? Because t is our time reference on the current. Okay, on the present, not the current, baka malito. On the present time na ina-evaluate natin yung circuit. Okay? So, if this is in t, then yung t dito, mapupunta dun sa labas. We need to change the variable if that is the case. Okay, so therefore, okay, so syempre mawawala na to. So, our VC of t is now equivalent to 1 over c, since c is a constant, multiplied to the integral from negative infinity to t of I, let's say, tau d tau. Okay, so eto ngayon yung gagamitin kong relationship ng VC of t in terms of I of t. Okay, so if that is the case, okay, so let's substitute. So we have dito na lang rin natin ilagay, no? So our I of t is the same. So we have here, sige, dito na lang. Vs of t is X of t. Then our I of t is Y of t. So we have Ry of t. Okay, then we have plus, so Vc of t is equal to this, 1 over c multiplied to the integral from negative infinity to t of I tau d tau. Okay, so anong gagawin natin dito? No, so we can just divide or rather change sorry, 1 over r dapat to eliminate r, because remember y of t is our output, no? So if that's the case, so we are going also to change I of t into I of tau into y of tau. Okay, so we have 1 over r x of t. Okay, so this is equal to y of t plus 1 over rc of the integral from negative infinity to t of I, or rather of y tau d tau. This is the answer. Okay, so that is the relationship of the output and the input, okay, for this particular circuit. Okay, now let's have this one, no? So consider the capacitor, okay, in this problem. Okay, so find the input-output relationship and determine whether the system is memoryless, causal, linear, and time invariant. So it's very crucial for us to determine tawag dito, the circuit that is rather the equation governing the circuit, no? Bakit? Because that will tell the properties of the system. Okay, now let's use, okay, let's analyze this problem. Okay, now we have here y of t, no? So let's just go to the representation of a general system, just general representation of our system. Y of t is equal to x of t. Now, since our y of t is equal to vc of t, okay, and our x of t is equal to I of t, okay, we can relate that the vc of t, the voltage across the capacitor, is just the same with the previous one. No, so alin dito? Ito. Okay, we're going to use this. No, so for this, okay, so we have here from negative infinity to t of I tau d tau. Okay, then change lang natin, no, yung variables natin. So since vc of t is equal to y of t, x of t is equal to I of t, so we have here y of t is equal to the integral from negative infinity, 1 over c, nakalimutan natin. 1 over c from negative infinity to t, okay, of x tau d tau. Okay, so this is the relationship of the input and the output. Kasi napalitan na natin ng x of t and y of t. No? Yung t, of course, is represented in tau because of the boundaries. Okay, now, so for, let's determine if this is memoryless, if this is causal, linear, or time invariant. No, so for the first one, it is seen, no, that the output y of t is dependent on the past and the present. Okay, meron tayong dependency, no? Bakit tayo nagkaroon ng dependency? Because, okay, if you're going to evaluate this system, okay, meron tayong charge na involved. Okay, and remember, charge is dependent on the previous voltage applied on the system. Okay, so if that is the case, therefore this is not memoryless, no? So wala palang dependency, x of tau lang eh. No, so ayan, sorry for the confusion. No, because x of tau lang, wala naman tayong ang tawag dito? Sorry. Yung kanina, no, yun nga, yung sinabi ko kanina. Asan ako? Wait lang, sorry for the confusion. Medyo nalito lang ng slide. Okay, the system is with memory, no, because of the charge nga, no. So lagay natin dito. Palitan ko lang yung pen ko. So this is with memory. Lagyan natin sa baba. Or this is a dynamic system. Now, is this causal. Okay, so since the output does not depend on the future values of the input, okay, hindi naman natin na-determine ano yung future charge, okay, nung capacitor natin, then therefore, okay, the system is causal. Kasi wala naman dependency on the future. Meron saan? Sa present and din sa past. Okay, now, let's check if this is linear. Okay, so we're going to have, so dito na lang sa taas, so our y of t, okay, I mean this one, no, so palitan lang natin yung ating y with y1, okay, this is equal to 1 over c of x1 of tau d tau, okay, then yung pangalawa 1 over c integral from negative infinity to t of x2 tau d tau. Okay, then let's multiply. Okay, the first one say with a, para hindi na nakakalito. Then this one with b. So we have ay1 of t is equal to 1 over c multiplied to the integral. Since constant naman yung a, pwede natin ipasok yan dito kasama ni x1 of tau d tau. Ayan. Okay, then we have here by of 2, y2 of t. So, ganun din, papasok din natin siya sa loob nung integral. So, we have bx2 of tau d tau. Okay, now, let's add both equations. So, we have ay1 of t plus by2 of t. Okay, since constant si 1 over c, labas. Likewise, yung integral, wala namang effect on the addition. Okay, so we're just going to add yung ating integrand, no? So we have ax1 of tau plus bx2 of tau. Of course, si d tau hindi naman siya affected, no? Wala naman tayong pinalitan kay d tau. Okay, so since ay1 of t and by2 of t is just y of t, and this part ax1 of t and bx2 of t is also I mean this just also x of tau. Okay, then therefore we go back to the original equation. Y of t is equal to 1 over c multiplied to the integral from negative infinity to t of x tau d tau. So therefore this is linear. Ayan. Okay, so this is linear. And last, no, is this time invariant. Okay, so let's check, no. So we have here our y1 of t. Okay, so let's change the input. Okay. Of t minus, let's say, sige, wag na natin gamitin yung tau para hindi kayo malito. Ayan. T-nut na lang. So, let's change, no? So, of course, we're going to change this one from x of tau to x of tau minus t-nut. Ayan, para hindi confusing. Okay, so, if this is the case, no? So, we can just say that we can transfer this tau minus t naught dun sa taas ng ating boundary, dun sa upper boundary natin, and change to another variable. No, so that is 1 over c multiplied to the integral from infinity to tau minus t naught of x say lambda d lambda. So this is our what? Our y of t minus tau, which is also our y of lambda. No, so if that's the case, since our y1 of t, okay, is the same, okay, hindi naman siya nagbago dun sa ating, I mean, same lang yung nasa loob, no, nung nagpalit tayo, nung nag-shift tayo from x of t minus tau, t minus t naught to, from x of t to t minus t naught, ay nangyari sa output is ganun lang rin naman. Okay, so therefore, this is time invariant. Ayan. Okay, so again, our system is with memory, it is causal, it is linear, and it is time invariant. Okay, so this example number 3 na solve na natin to kanina no dun sa modulator no. So okay. That's for the classification of systems. I hope you guys learned something no. Sana malinaw yung discussion natin. So next topic we'll be talking about convolution of DT and CT signals. Stay tuned. Okay, thank you very much for listening and God bless.